I'm Jaimee-Lee.
Hi, I'm Ruby.
Hi, I'm Jamie.
Hi, I'm Josh.
And I'm Celeste, and we're exploring primary school content descriptors for the physical and chemical sciences.
Our team are quite bright sparks, if I do say so myself, and we thoroughly enjoy making electrical circuits.
So we're excited to bundle up all of our kinetic energy and academically entertain you for the next 15 minutes. Come on!
So what have we learned throughout this course, guys?
Well, if you look at the Australian curriculum, there are 4 sub-strands located in the science and understanding strand. These are biology, chemistry, physics, and earth and space science. In this course, we narrowed it down just to chemical and physical sciences. Chemical science, looking at what materials and objects are made of, how they can be combined for a particular purpose, the change in state, and whether materials can be reversible or irreversible.
Whereas physical science looks at the way objects move, light and sound, push and pull effects, forces, light forms, and electrical energy. During the experiments we conducted over the last few weeks, we came to understand that properties held within physical and chemical science.
And the physical properties can be observed and measured without changing composition.
Oh, so the chemical properties are like the opposite of that, and they can be changed by the composition of the materials.
Yeah. And we looked at these learning topics through conducting numerous experiments and recording these in our EISN book, focusing on push and pull, change in state, adhesion, heat transfer, concentrating on convection and electrical circuits with the transmission of light.
Yeah. This level of understanding of science concepts wouldn't have been possible without the weeks 1 and 2, where we really focus on the importance of scientific literacy and the nature of science.
Yeah, and we also looked at science's teaching pedagogical process, which was the 5 E's, and we looked at why that was so important when teaching primary school science. We learned that this method was guided by a more inquiry approach, where students are supported to work scientifically through hands-on learning experiences.
Yeah, and we also learned that like every year we're expanding on our knowledge, as we've learned that a Kara builds upon knowledge every year, developing new ideas and drawing on current scientific knowledge. And definitely it leads into expanding on prior knowledge and understanding, which draws from students' hands-on experiences, which increases their content knowledge.
Okay, in a Kara, that's known as the sequence of content.
Yeah, and that was really similar to when we did electrical circuits. Students were asked to use their prior knowledge on conductors and insulators to learn the topic. This meant that the introduction of electrons and how they're transferred throughout a circuit was building upon their previous lessons experiences. So why don't we now take an in-depth look at how some pedagogical approaches were used during this course were used in our experiments.
Cool.
The 5 E's were easily portrayed across each lesson, especially the engage phase. It was easily able to be included within each lesson, and it was important to create interest within the topic and draw on students' virtual backpacks, conducting a formative assessment on their prior knowledge and seeing what they can bring in to this part of the experiment. It was quite easily transferred into all of the labs, the learning labs,
Yeah, so whereas the explore phase, it was giving students the concrete understandings through the hands-on experiences.
Yeah, and it during this phase it also allows students to create a hypothesis.
Yeah, so they could do that using like the cows move softly, the predict, observe, explain through the teaching methods.
Yeah, and it's also vital for students during this explore phase to record data as well.
Yeah, definitely.
And then moving on into the explain phase, students will start to explain their current understanding, which communicates and develops into their final hypothesis. Students will teach the teacher and the class as they communicate their findings, justify why and how in relation to the lab and the hands-on activities.
Yeah, this creates an opportunity for the teacher then to fill in the gaps from their current understanding into their CDSU.
Yeah, which can also be done in a really creative way, which gives the teachers so much teacher autonomy, which is a great opportunity for project-based learning.
And it will also enhance the students' scientific literacy, and this could be done within the classroom using a word wall, for example.
We also noticed that it was impossible to incorporate all 5 E's within the lesson. We could incorporate the first 2 and maybe the first 3, but we found elaborate and evaluate really difficult to incorporate into a single lesson. And that's just because science is taught over a unit, not just one single 30 or 40 minute lesson.
Yeah, within those 2 last phases as well, it's also an opportunity then for the teacher to either sneakily do a bit of a formative assessment, or in the last phase, yeah, they could do that summative assessment.
Over the last couple of weeks, we've discovered and explored a lot of pedagogy and what approaches are appropriate within science. We've found that the constructivist theory and approach is very strong within the science. It's an ideal pedagogy approach as it focuses on hands-on experiences for everyone in the classroom. It switches between teacher presentation and teacher engagement, and engagement of the students, which allows learning through hands-on activities.
Yeah, I think the other thing that we looked at throughout the weeks was the CDSU content that we were looking at when conducting the experiment was quite content heavy and in more of an adult focused language. So something that we definitely learned was that we needed to simplify that to make sure that the experiment and the age group and you know, the types of children that we're going to have in the classroom, we're going to use language that's appropriate for that as well. So yeah, making sure that the explanations are delivered in a science concept that's child friendly.
Yeah, so using the gradual release of responsibility, it kind of helped to ease the transfer of knowledge. And as a teacher, it's our responsibility to make sure that children have had plenty of opportunity to explore and learn science inquiry skills.
Yeah, definitely. And we do that through like asking them open-ended questions to really get them to think and inquire.
And just that in itself is allowing students to move away from that alternative concept phase and more into that CDSU phase. So really growing their knowledge on science concepts.
I did notice that something we weren't able to include throughout the weekly labs was the TWLA charts during the explore phase especially. Yeah. And I definitely want to try and incorporate that within the classroom because I think it'll really help enhance student participation and like a great reflection of what students learned and what they wanted to learn. And just at the end of the lesson to be able to go over that with them.
Yeah, definitely. I think it also makes a really good reference for formative assessment if you have any, like a collection of the students' work. That's true. Yeah.
So then the TWL charts, you know, we saw, you know, during the lectures that was represented on a whiteboard as a whole class activity. But if we were going to use that as more of an assessment piece,
you just
then
get them to individually do it in their books.
Yeah.
I suppose it varies, but what each kid wants to learn and what they did learn, because
it can be quite like individual.
This unit dove into Year 6 Science Understanding strand, specifically physical science and the ways electrical energy can be explored in the classroom. The content description used was that electrical energy can be transferred and transformed in electrical circuits and can be generated from a range of sources. The 3 elaborations, which are easily interrelated and could be incorporated into electrical energy unit, include recognizing the need for a complete circuit to allow for the flow of electricity, investigating different electrical conductors and insulators, and exploring the features of electrical devices such as switches and light globes. But how do we make the topic of electrical energy fun? Well, you could start by organizing circuits to spin a fan or sound a horn, or better yet, replace the battery with lemons. Teachers could expand on students' current understanding and teach the differences between incandescent light versus LED light bulbs, which would tie nicely into educating students about posthumanism. This would allow students to make deep interconnections, but we'll expand on that a little more later in the video. I now want to show you a little skit our group put together to highlight yet another way electrical energy could be taught in the classroom.
I'll have to text Electron.
I need light, mate, to read my book.
keep up with the times and buy a Kindle already. Fine. Have your chemical reaction and I'll round up the others and we'll be there soon. Hey battery,
Hey.
you know, you can't expect me to go all the way to switch without a little bit of help.
Fine, I'll give conductor a call.
Hey girl.
Hey, Electron needs help turning on the light.
No worries, I'll be there soon.
Thanks.
Hey guys, so great to see you as always. You know how much I love giving Electron a helping hand. Follow me.
Alrighty.
Can I see some ID?
I'll wait for you on the other side.
Fine.
Electron, eh? Can't you see I'm off? This means I'm a circuit breaker. You'll need to switch me on for you to reconnect that circuit of yours.
Woohoo! See ya later, Switch.
Hey Lightbulb, do you think you can illuminate the room?
You know, I'd love to be the center of light.
I'll give you a little bit of electrical energy.
I feel so energized now.
Woohoo!
I can see now. Thanks guys. Keep up the good work.
As you saw, this was a visual representation of electrical circuits incorporating all three of the electrical energy elaborations on the ACARA website. As the teacher, you could set the task for students to make their own skit, which would be student-led and project-based learning to demonstrate their understanding on the topic. Now let's look at the scientific literacy that needs to be explored for our Year 6 students to understand electrical circuits. The first piece is the source, the battery. The battery contains chemical energy that reacts with each other to make electrical energy. This provides a push to make electrons move. Electrons is another piece of literacy students must understand, as they are central to energy transfer as they carry the electrical energy around a circuit. Students must also understand the wording resistor or bulb. This transforms the energy from electrical energy into what is required. For example, a bulb transfers it into light and heat energy. Now let's cross back over to Jazzy, Jamie and Ruby, who will discuss the health and safety considerations.
So I think we all agree health and safety is our main priority and especially important when teaching science concepts.
Yeah, like the other week when we looked at electrical circuits, it's important that students are able to identify the risks.
Yeah, and especially the risks to themselves, because we can all agree that we want to keep the students really safe. So the risks with electrical circuits will include the light bulbs, because they contain glass.
Yeah.
Wires, because they can be sharp, and then batteries. But obviously when it comes to batteries, we are using a low voltage, so just making sure that students understand that the low voltage batteries that we're using are completely safe.
And I think that's why we had the mitigation strategies in place as well, just so the students knew to go to the teacher if they had any issues or any problems. And we went over it all before we actually conducted the experiment with the kids.
Yeah, and it's important for students as well to realise that not only do we have to look after ourselves, but we also need to look after peers and others around us.
And the classroom environment as well.
Yes, 100%. So the mitigation strategies for that would be just carefully handling the equipment,
maintaining clean environment, classroom.
Yeah, so pushing in chairs, making sure there's no trip hazards on the floors,
cleaning up any breakages. If the light bulb is dropped or anything like that.
I guess also making sure that students have got a really nice relationship with the teacher in order to be not embarrassed if something breaks either, to come and talk with us if a chemical is spilt or something like that, making sure that they're not quickly trying to clean it up themselves.
Yeah, definitely.
They always know that they can come to us and we can fix it up. And I guess the only other thing is just making sure that students pack everything away when you're finished.
Leaving the classroom how it was found.
Yeah. I guess one of the other things for health and safety would be about really as a teacher considering where should we conduct the science lesson? If it contains water, should we be doing it on the classroom carpet? Should we be doing it at their desks? Maybe outside might be a more appropriate place.
The ACAR website has an array of work samples for teachers to identify appropriate achievement standards for different criteria. As you can see, teachers are given 3 different levels of achievement to base their marking and criteria from.
I think we've exhausted our bachelor for today. See you next time.